All right, so we're looking at, this is video number 2, which is linear inequalities in module 1. And a couple of things to think about when you're thinking about inequalities. First of all, we have the less than or greater than, or less than or equal to, or greater than or equal to. The only difference between them is really whether you are including the value that you're looking at or if it's just over. So if I wanted to say, give me a number that is greater than 5, you're going to look for a number that is 5.1 or 10, but you would not be able to say 5. If I asked you for a number that is greater than or equal to, then you can give me 5 or 5.1 or 10 or a million, and you would satisfy that inequality. So you want to think about that. The only other thing you have to watch is when you're dividing both sides by a negative. And that's when you have to flip that inequality sign around. And I'm sure your Algebra 1 teachers have gone over that in great detail. But that's one of those key reminders that you want to look for as you're taking this Keystone exam. So let's look at a couple inequalities here. Here's a simple inequality. It might look just like a two-step equation, except you've got the inequality sign there. With a compound inequality, you actually have two inequality signs, and they could be joined by and or. Now, in this situation here, there's no word joining the two inequalities, but because of the way it's written, it's understood to be an and situation. If it were an or situation, you actually would see the separate inequalities, and you'd have to see the word or there. So in solving a simple inequality, you're going to follow the same process pretty much as solving an equation, except that when you have to divide both sides by a negative, you're going to flip that inequality. So let's look at an example here. So we've got this negative x over 5 plus 3 is greater than 10. So our first step is we are definitely going to subtract 3 from both sides, just like we would if this were an equation. We're then going to have that negative x over 5 is greater than 7. Now, I put notice how I move that x up into the numerator. I like to do that so I don't lose my sign. Oftentimes, if you stick it right beside your fraction, it tends to look like just an extra long fraction bar. So then my next step, and I'm going to break this into 2 steps just for the sake of this video, is I would multiply both sides by 5. Okay, so if I multiply both sides by 5, that's a 5 there. I'm left with negative x is greater than 35. So my final step is I'm going to divide both sides by a negative 1 so that I can solve for just x. Now, what did I say? I'm dividing both sides by a negative. So in this situation, you have to be careful as you divide by a negative 1. I kind of do a little thing like this to know that I have to flip my inequality sign. So negative x divided by negative 1 is just x. I'm now flipping my inequality sign, and then I'm left with negative 35. Okay, so we're looking for where x is less than negative 35. Think about a number. I'm going big. I'm thinking negative 100. So if I plug in negative 100, because I know that is less than negative 35, into my original equation for x, and continue to check my work, this here results in a positive 20. 20 plus 3, is that greater than 10? Most certainly. So there is my quick check to make sure I did it right and I didn't make any errors in my work. Okay, so we are moving on to our next inequality here. And we're talking about graphing inequalities. So as we are graphing inequalities, you want to make sure that, what did I do there? Okay, that when you're graphing them, you think about x is greater than negative 3. So in this case, we're looking and finding negative 3, and where is x? Where are the numbers that are greater than negative 3? That is to the right, so we move our arrow to the right. Now notice I didn't fill in the circle. In the next inequality, I have x is less than or equal to 4. So in this case, I'm looking for the number 4, just like we had at the beginning of this video, the conversation about I can include the 4. So I definitely want to make sure that I fill that in. So if we look at this inequality here, we've got the -3, x is greater than or equal to -3. So the first thing we can do is eliminate this and this because both of those inequalities don't have the equal to sign. So then we can pick one, and I'm just going to pick the bottom one here, and we get 2x plus 5 is greater than or equal to -1. If we subtract 5 from both sides, we're left with 2x plus 5 is greater than or equal to -6. Oh, I'm sorry, that's not there anymore. And then we divide both sides by 2, and we get x is greater than or equal to -3. So we know it is this one right here. The other thing we can do is look at our solution set, and notice 0 is included in this solution here. So you could plug in 2 times 0 plus 5 should be greater than or equal to -1. That works in D. It does not. 2 times 0 is still 0. Plus 5 is not going to be less than or equal to -1. So that we can also eliminate B from that. So moving on to our next slide here. We're looking at compound inequalities. Remember, compound inequalities are going to be two inequalities that are joined by usually an and or an or. So if we look at this next example here, we've got this compound inequality, and what I want to recommend doing is breaking it down into both the less than part and then the greater than part. And because it's written this way, we know it's going to be joined by an and. Okay, it's going to be joined by an and. As we start to solve this side and this side, you get y is going to be less than -1, and then y is going to be greater than -4. So we can rewrite that as a compound inequality, and there we go with B. So when you're graphing compound inequality, so you're going to graph something like this, you're just going to graph both parts. Okay, and we're looking for the and, so we're looking for the overlap. So we're looking for numbers that are going to be greater than -4 and numbers that are going to be less than -1. So it's actually this, what I like to think of as a barbell here. Between the -1 and the -4 is going to be our solution. Okay, so we've got another example of a compound inequality, and this one is joined by our or situation here. So you're going to solve these the same way you would an equation, combining like terms, getting all your variables to one side, your numbers to the other. So in this case, I added 10 to both sides and subtracted 9x from both sides to give me -19x is greater than +19. Now, in order to solve for x, I have to divide by a negative. And this is the one thing that's different about inequalities than equations. When you divide both sides by a negative, you have to flip that inequality sign. So that's why I put that little circle there to remind myself to flip it. And then I've got x is less than -1. Or I solve the second one here. And so I can, again, I'm subtracting 10x from both, subtracting 10x from both sides and adding 2 to both sides. That results in -7x is less than -7. Divide both sides by a negative. And again, I have to flip that inequality. It's going to be greater than, so x is greater than +1. So then when we go to graph it, we graph this over here. So it's x is less than -1. So that's anything from here over. Or x is greater than 1. And we can pick from here. So you're kind of picking from either side of this little system here. Okay, that's